Hi, everybody. This is Joanne, Science Goddess on Twitter, and one of the hosts, Science Goddess on Twitter, and one of the hosts, along with Jeff Schomeyer of Read Science. And today we welcome author Sam Kean, who has written 4 marvelous books, which I have read all of them. So Disappearing Spoon, of course, burst onto the scene, and everybody thought it was wonderful, and it became a national bestseller. And so I love that book. I have to say that all the time. And then his second book is The Violinist's Thumb, which I listened to, so I have that. So in case you haven't seen the picture, Violinist's Thumb. And then the third one was The Tale of the Dueling Neurosurgeons, about the brain. And then his newest book is Caesar's Last Breath, Decoding the Secrets of the Air Around Us. Sam, why don't you say hi to our guests?
Hi, everyone.
Viewers.
Thanks for having me on the show. I appreciate it.
Yeah, I'm really glad you're here. So let me read Sam's bio, which maybe you know now he writes books. Sam Kean is the New York Times best-selling author of Caesar's Last Breath, The Dueling Neurosurgeons, The Disappearing Spoon, and The Violinist's Thumb. His stories have appeared in the best American nature and science writing, The New Yorker, The Atlantic Monthly, The New York Times Magazine, and Slate, and his work has been featured on NPR's Radio Lab, Science Friday, and All Things Considered, and Fresh Air. So these are all marvelous places, and all of our great science writers tend to all visit there. So Sam, we're really glad you can join us. Jeff, I'll let you throw out the first question.
It's nice to have you, Sam. I loved the book, and I think all of your readers are going to be overjoyed at this one if they liked what you wrote before. Okay, this is an essay question this time because I was reading about gases. No surprise, but I was reading about illumination by gas, and it made me think of when I was, as I was thinking, in my larval stage of becoming a physicist. And I was working in the undergraduate lab where you're doing spectroscopy experiments. And the one experience that I really remember visually, I think, was working with gas discharge tubes. And I know we had neon, helium, hydrogen, some others. So I want you first to explain a little bit what I mean when I'm talking about gas discharge tubes and why that comes up in the book. But what I'd really like then as a topic is, can you compare, contrast for us how humans experienced the nighttime before 1800 and after 1800?
Sure. So what you're talking about with gas discharge tubes is just a different way of providing light, providing illumination for things. Light bulbs, especially older light bulbs, they would have something that was incandescent. So you would heat something up, like a tungsten filament or something, it would start glowing, and that would provide light. But another way to produce light is to run a current through a gas and basically excite the atoms in there, get their electrons excited, and they produce light that way. The electrons moving up and down, excited within the gas atoms, produce light. So it's just a different way of producing light, and it has some advantages that are nice to have in certain situations. So gas, in street lamps, you often see sodium discharge or things like that. So it's just a different way of providing illumination. And it comes about in the book because the book sort of looks at a bunch of different gases in the history of human civilization, talks about them, talks about how they've affected human beings, not only our biology, but have affected our civilization as well, particularly during the Industrial Revolution. And one of the things I talk about is how gases provided illumination really for the first time. Before that, before about 1800 or so, we had sources of light, things like candles and fires and things like that, but they were really poor sources of illumination. There were jokes among historians about how basically all they did is make you realize how little you could see around you. They made darkness visible, was the joke. But after that, once gases started to come online, things like natural gas and other forms of illumination, people really started to have illumination at night for the first time. And it changed society in several ways. It allowed people to be out more at night. So the idea of nightlife really got started. It made streets much safer at night because they could put up things like street lamps and, keep areas illuminated so you didn't have criminals lurking all over, things like that. And it also changed the workforce in that people didn't have to go home suddenly when the sun went down. You could have people staying regular hours all year long. So work became a little more regular, a little more regimented in some ways as well. So it not only expanded nightlife, kind of the fun part of it, but it made work more regular too. So added to some of the drudgery as well.
Dark these days seems like it is such a rare commodity that it's something that we value. And I was trying to imagine, it's romantic to think, oh, think how dark it was, and you could see the Milky Way, and wherever you were and stuff like that. And then the realistic side says, I bet people weren't that romantic about just dark all the time because there was nothing you could do about it.
Yeah, it wasn't something that they thought about as a privilege the way we do nowadays. In fact, during that section in the book, I talk about how darkness has actually become the precious commodity nowadays. You see, astronomers who are desperate to find places where there aren't illumination around, or even in our daily lives, as you mentioned, being able to look up at the sky and see the Milky Way, actually see the stars, is kind of tough nowadays. You have to go through a lot of work to find a place where you can see the stars. So our whole concept in some ways of what the night is and whether the night is something that should be scary and banished or something that should be precious has kind of changed nowadays.
Yeah, it's kind of a big shift. And I was noticing that, not surprising since you're talking about history and stories and things, that you touch on a lot of milestones. But when I've read most books, I've seen the milestones as, oh, and then this happened, and then this happened. And I was interested to note that the feeling I got from the milestones in the stories that you talked about were more about the before and after and how things changed for everyone. So people found this use and started burning this coal gas in order to illuminate things. And that made a big change in how we valued the dark and how we saw it. Or talking about the development of the steam engine. Fine, there's the grand man, the story they tell, the milestone of here's the steam engine. But the way it changed people's lives makes it a big before and after story. So I really enjoyed the before and after aspect of all these stories.
Yeah, that is something I do think about, I guess, in that I'm really very interested in human beings and human nature, and especially what has been consistent and constant with human nature over time. So I love reading about, like anthropology or something where you read about, you can see glimpses of modern society, modern civilization, even when you're talking about things that happened, or civilizations or ways of living that existed thousands of years ago. I love seeing the continuity between older ways of life and modern ways of life. But I think there are times where you do see definite changes, definite breaks, things that do really change our relationship to the natural world, to each other. So I really find those befores and afters fascinating. I guess I hadn't, been consciously trying to put it in the book, but now that you mention it, it is kind of an interest of mine. So I'm glad it kind of.
Well, it did. Obviously, it made me start thinking about those before and afters because we know that it's not like we sort of have science fiction now and things to say, well, people were thinking about flying, for instance, and machines for flying before where there were machines, so they could think about it. But there are an awful lot of things that people don't even think about or talk about or long for or understand. There's nothing about it until this change has happened. So the idea of the Industrial Revolution, there was no idea of what steam might bring along. And I was really affected by this idea about light and dark and how our relationship to it must have changed so much because we don't think very much about the dark. And so it was, it was a valuable thing for me to pause and think about that. So thank you for that. But I also was thinking, as I was reading these stories, is that people who've read your books before will come back and they'll read this one because they know that you like to tell a series of good stories. And these stories, and I think this is Caesar's Last Breath is an excellent example. These stories all seem to contribute somehow to the idea that you're using to organize and make everything coherent, which works particularly well for me. And I'm wondering, well, I'm trying to figure out how that magic works because that would be nice to know. But for the communication thing, it made me wonder if you could talk for a minute about your research and your development process.
Right.
Do you have this idea for the theme that you're going to have and then do the research? No, maybe do you start doing the research and do the stories tell you what it is? I'm thinking it's going to be a back and forth refinement, but I'd like to know about how you find these stories, where they come from, and then how they come together into something.
Sure. It is more of a back and forth process where both those ideas kind of feed into each other. I do try to read widely and read about, any topic that might be of any sort of vague interest to me. So I don't try to stick with just science or things like that. I try to read novels. I try to read lots of nonfiction books, lots of history, all sorts of things, just to find, little threads or little stories that I think might be interesting to write about in the future. And then I have sort of this file I keep of, interesting stories, anecdotes, topics I'd like to write about, something like that. And every once in a while, I'll go through and add a few things to them, delete a few things, or just read them and see if anything is percolating, anything kind of grabs my interest. And then when it comes time to write a book, I sort of look them over and decide, well, is there any sort of common theme there or a central idea that I could kind of link everything to? And at that point, I really start to develop the idea of what the book could be about. And as you mentioned, in each of my books, I do like to take a central theme, something like the periodic table or the human genome or the atmosphere, and then jump from there into stories about all sorts of different areas of human life. So I really like that idea of being able to have one central idea, but not being confined to that idea, to being able to jump to a lot of different things. I think it makes for a more entertaining book. And in all of my books, what I really try to emphasize is the stories in them. I always try to emphasize that there's people involved, that there are heroes and villains and drama, things like that. And for me, the story is really where I want to start with with each chapter. I want to make sure there's a good story underlying each chapter, or, in some sense, why bother writing about it? If there's just some little anecdote or something, I feel I can weave it in there. But I really want to make sure there's a juicy story involved before I invest too much time or effort into it.
Well, I think Joanne will agree with me that in our Read Science area, one thing that we celebrate is we like stories about science just fine. But we are always happy to find stories that are not necessarily about science, maybe about scientists, maybe not. But when they encounter the science, they take it on and talk about it as part of the story rather than putting it off to the side. And that's the feeling I get. If there are all these interesting stories and people and events, and by golly, science was there and it works its way through as long as you're keeping your eyes open. That's something we like to see, isn't it, Joanne?
Oh, definitely. And it makes me wonder, so do you have a strong background in science or just a keen interest in it? Sorry. I should have to say, whoops, inadvertent pun.
Yeah. No, I do have an interest in science, and I studied physics in college, so I have that background there. Yeah,
I'm outnumbered once again.
Yes.
Yeah.
I'm a biologist.
But I also did study English literature there as well, so I feel like I have kind of the background in both of them.
Okay, and so you said, you know what, I'm a better writer than a physicist? Is that sort of what happened in your life? Or?
Well, it was sort of a like a natural selection process, I guess, in that I liked my science classes and did well in them, but just temperamentally, I could tell I wasn't cut out to be a scientist, in that I admit, for one thing, I was not the best in lab classes, especially. That was a little clumsy, wasn't my forte. And once you get into a real science lab doing real experiments where you don't know the results of the experiment necessarily, it can be pretty frustrating. You spend a lot of time building equipment, troubleshooting equipment, floundering around, not knowing what you're doing. There's a lot of that in science, more than I think a lot of people realize, and it can be very, very frustrating for some people. Some people like it. They really like the tinkering with the equipment, the mystery, the problem solving. But I just found it very frustrating and realized eventually that even though I liked science overall, that specific aspect of it probably wasn't for me. And the other thing I didn't like so much is nowadays in science, if you want to make a contribution, you really have to specialize a lot. And yeah, and it didn't appeal to me as much as knowing about science in general. So writing about science gave me a chance to not have to specialize. I could cover lots of different topics, which I found a lot more appealing.
You're right. Most scientists have to, now they're, at least in biology, you're down to one molecule and that's it, right? It's very, it's very funny. You're not the first person to say that you became a writer because you're not really a lab person. And maybe that's why I'm not a writer, because I love the lab work, right?
Okay.
It's very funny. So would you be open to any field of science? You've obviously tackled the genome, and but I guess you've got 2 biology books and 2 chemistry physics books.
Yeah, I guess they fall into those 2 topics. And those are probably the areas I've written most about, not only in the books, but in, magazine, newspaper articles, things like that as well. But I wouldn't rule out, writing about any subject of science, as long, again, as there was a story that really intrigued me, that I found very interesting, and felt like it would sustain me long enough, sustain my interest long enough to get a whole book out of it, because you're really investing a lot of time, energy. So want to make sure I enjoy the characters. I find the story intriguing, rewarding to think about. But beyond that, there's no area of science that I would really rule out and just say, I don't think I could touch that at all, something like that.
What I like about your books is, I could just feel your enthusiasm for the topic. There's just no doubt that you're enthusiastic about this, especially thinking about how much research it takes. You've got to have a lot of curiosity and enthusiasm to really get in there and do all of this. So that's been one of my favorite things about your books, and that you're not afraid to use some phrases more serious scientists or writers would not use. You don't mind using colloquial phrases and puns and things like that. It's great fun, actually.
Oh, that's good to hear. I do want people to come away from the books thinking that science can be fun, that you can you can laugh while you're doing science. You can have a good time. It can be enjoyable. So I don't want people to, we all know science is important, but people should know that it's, a human activity too, and that all of the human emotions that we feel in daily life are part of science. They can be involved with science. So I'm glad to hear you say that. I like to get that idea across.
I think, Joanne, one of the things that amused me the most was that the feeling that there were so many stories. Virtually every turn seemed to have another story that came with it. And then when we were in the midst of a story, there was an asterisk because, well, gosh, there was just more to that story and some things budding off over here that wouldn't quite fit in the page. And then you go and you read the fascinating stuff that's back in the asterisk. And by golly, there's a website and things, because, the story just doesn't stop.
Yeah, I'm not the best about letting things go, and I really get excited about them. So,
but no. The point is, there always is more. But yes, you did, I think, draw a nice, if sometimes blurry line, but that's okay. I like the depth, but you kept the narrative moving along, and that's that's not so
Yeah,
easy.
yeah, that's exactly what the asterisks were for.
Yeah.
So it didn't bog the story down, but I didn't feel like I had to throw away these really great nuggets. So it was kind of a compromise between keeping the story going, but not throwing them away either. And then the website went even farther, where things that, you know, I still liked, but just didn't have room in the book, and kind of wanted to put them there.
All sorts of juicy and tasty tidbits. Another milestone. Well, no. Yes, a milestone, say, but one idea, one of the big ideas that really appealed to me, and it's good for people to learn more about, is what you call the 4 atmospheres of Earth. Can we do like all 4 atmospheres in 2 minutes, just as a reminder that what we have with this amount of oxygen and plants that do photosynthesis and things wasn't really the rule for most of history?
Yeah, that wasn't something I knew a lot about before I got started writing the book, and it really is a fascinating topic. So, you know, the numbers are a little blurry, but geologists, people who look at Earth's history, roughly divide our atmosphere's history into 4 distinct phases. The first one was a very wispy atmosphere in the very early Earth, just some hydrogen and helium that kind of was left over from the formation of the sun. So that blew away pretty quickly, but it was the first atmosphere we had, the first gases surrounding the Earth. Then you get into the second atmosphere, which is basically volcano exhaust. So a lot of carbon dioxide, and then nasty gases like ammonia, sulfur dioxide, methane, things like that. So very reactive gases, hospitable to life, or inhospitable to life, I should say, things that would not have been friendly to life at the time. So kind of a dangerous atmosphere from our point of view today. And then gradually that gave way to a third atmosphere, which was dominated by nitrogen. And nitrogen also came from the volcanoes, but it was a very small percentage of any one volcanic eruption. But the difference between nitrogen and all of these other gases, all of the other volcano exhaust, is that because these other gases are reactive, they react with other things, and then they disappear over time. So they kind of fall out of the atmosphere in a way that nitrogen doesn't. Once nitrogen gets into the atmosphere, it tends to stick around for a very long time. So as the nitrogen started to build up, it became the dominant gas in our atmosphere. And the third atmosphere was dominated by nitrogen. And then eventually you got to a fourth atmosphere, which is kind of the one we have today, in which nitrogen's still the dominant gas, but there is a lot of oxygen around as well. And most of this oxygen came from living organisms, microbes at the beginning who were photosynthesizing, and then later plants. So just a rough overview of the 4 different atmospheres we've had in Earth's history.
But I like the insight that it gives, that plants evolved, animals evolved, plants and animals evolved together with the Earth as its atmosphere was evolving, because you couldn't have these without these, so these made this, and then this changed this, and the animals that can breathe now could not have breathed 3.5 million years ago, but got taken care of. And so when we get to terraforming, we want to take along the phytoplankton or something. It's just
like
it's
learning to crawl before you walk, right?
Yeah, it's a great story.
Slowly build a new atmosphere. So, you know, I like, you know, so you're talking about volcanic gas. One of the main characters in your new book is Harry Truman. Is that
Harry Truman? Yep.
Yep, that's his name.
The other Harry Truman. Yeah.
Yeah.
Right, and that was so fascinating. And I think I vaguely knew about him, but I felt like I got to know him so much better through your book. So, would you say? So, I'd love you to tell our audience a little bit more about him, but also, do you end up in your book saying, yeah, that's my favorite story, or that's my favorite character, like if that happens in your writing?
It's hard. I mean, there are definitely stories that you get attached to that you really like. It'd be hard for me to pick just one, but Harry Truman was one of the stories that I really, really enjoyed. You know, there was a lot more I could have put in there about him, ended up cutting a lot, but it was still a really fun story to write. So this is a story about not the President Harry Truman, but a different Harry Truman, who was living in Washington State in the late 70s, early 80s. and happened to be living basically at the foot of Mount St. Helens. He'd ended up there under sort of dubious circumstances in that he'd been a bootlegger, a rum runner during Prohibition, and had apparently angered a few too many people and had fled to this remote woods near Mount St. Helens basically to hide. He'd taken a machine gun up there and was hiding from people up in these woods. Eventually fell in love with the place, decided to open a campground there, had a few different wives throughout his life, but met the love of his life eventually, his third wife, Eddie, and they built a life up there, running this campground. He never quite got over the bootlegging. Even when alcohol was legal, he still had, these stills. He would hide in the woods. Always kind of a dubious character, but a charming guy as well. And just kind of living his life near Mount St. Helens. Sadly, though, Eddie, his wife, ended up dying in the late 1970s. It was very devastating for him, and he kind of fell into this funk after that where he just wasn't quite himself anymore. And life was just kind of going on for him. The days were just sort of passing until the Mount St. Helens started to give signs that it was going to erupt. And authorities were very worried about it. They decided to evacuate everyone from the area, except Harry Truman absolutely refused to leave. He said he didn't believe the geologists knew what they were talking about, but people who knew him a little better just realized, he'd built this life for himself and Eddie up there, and he was very nostalgic about it. He didn't want to leave. So he became kind of this colorful character and sort of a celebrity in all of the coverage about Mount St. Helens because he absolutely refused to leave the mountain. And he stayed up there right until that day in May when the mountain finally exploded. And just based on the geography and the geology of the mountain, it happened to explode, and not through its top like a lot of volcanoes, but it kind of blew out the side. And the side it blew out happened to blow right toward Harry Truman. So we don't quite know exactly what happened to him, but based on the fact that the gases were spewing out of the volcano at hundreds of miles an hour, that he was, a couple miles away from where it exploded, he almost certainly died. And based on what we know about the physics of the body, the human body, its composition, and volcanoes, there's a very good chance he basically vaporized as soon as this volcano hit him. So his body would have turned from a mix of solids and liquids into gas, probably went right up into the atmosphere and dissolved into the wider atmosphere. So there's a very good chance that a lot of Harry Truman is still floating around the atmosphere today, coursing into and out of our lungs. So this amazing story of his life has an even more amazing after story, I think.
Right, and that's where the Caesar's last breath comes from, is that you take time to analyze, okay, how many molecules would be in his last breath, and then what proportion of our current atmosphere is that, and how is it that we could, what percent of our breathing could possibly have some of Caesar's last breath in it? And I thought that was pretty impressive.
That is, yeah, it's sort of this classic challenge problem that they give to physics and chemistry students and ask them, what are the odds you're breathing a molecule of Caesar's last breath? And in the introduction, I talk about the problem, what you can learn from it, things like that. But yeah, the Harry Truman story is sort of a macabre extension of that in some way. So it's a fun story.
And when you talked about that and did the calculation in a careful but painless way, I thought.
Yeah.
Okay.
Yeah, and then you've talked about volcanoes and the length of life on the Earth and how many termites you want to have to help with global warming. The big problem that keeps coming up for people who talk about science is how to deal with numbers, particularly very, 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 very big numbers and very, 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 very small numbers, especially when you start putting them together, calculating whether we breathe indeed one atom of Caesar's last breath, pretty much with everything. So, do you have protocols? Do you have ideas? What tips do you want to give people who have to deal with numbers like that, talking to their audience?
Well, it depends a little bit. One of the points I was talking about in the Caesar's last breath problem in particular is there's kind of this tug of war between, deciding whether it's possible we're breathing a molecule of Caesar's last breath. So one thing you might consider is how small a single breath is compared to the entire gargantuan atmosphere. So in that case, you're dealing with a really, really tiny number. And when you're talking about how many molecules, on the other hand, are in a single breath, you're talking about a gargantuan, a huge number. So you have this tug of war between a very small number and a very large number. And in that case, actually, I think it can be almost helpful to show what the numbers are, not to use necessarily scientific notation or something, but just list all the zeros out there and kind of overwhelm people with how big these numbers actually are. So in that case, I think it's actually kind of helpful to see the numbers. I think the problem comes in if you're either listing too many numbers too quickly and doing a lot of calculations on them, or sometimes if you start to do some, advanced calculations on them. The calculations I was doing in this book mostly were things like adding, subtracting, multiplying, things people are more or less familiar with. So I think as long as I didn't bog them down too much in detail, it was all pretty straightforward math, even if I do, gloss over some of the details of what was going on. So it's harder sometimes, or you're dealing with more advanced computations. You run into that, especially, I think, when you get into some more higher level areas of physics. If you want to talk about modern physics especially, you just cannot avoid getting into some deeper mathematics. And then it kind of depends on who you're writing for. If you're writing for a little more advanced audience, maybe they want some of those details. Or one solution might be to put it in an appendix and say, hey, if you want some details, here you go. Here are some of the gritty details you can get into. But if you're not interested, here's the story, and we're just going to continue on. So those are probably the ways I would deal with it.
Yeah, but it still messes with my mind sometimes, some of these comparisons, like, oh, we breathe in more molecules each breath than there are stars in the universe. And those sort of things make me sort of like, shouldn't the stars in the universe be the most of anything that there is?
Yeah, but that's
not.
What you try to do, is you try to make those analogies and really capture people's attention. So that is one way to do it.
No, it can't be the most of anything there is, because stars are made of hydrogen. Therefore, there has to be more hydrogen. And it's probably true that the amount of hydrogen in one star is larger than the number of stars in the universe. And then I'm back to
back to mind blowing.
Yeah, back to mind blowing things again. Although I figured it probably reveals my physicist side, that you were talking about you're calculating how much of Caesar's last breath might be in the air and how likely we are to do this. And I thought all of those, I thought, this is a good calculation. This is very good, useful stuff. But what I was really interested in is how quickly it would take for it to have diffused enough that we would have a 50% probability of actually getting one of those molecules. So I was thinking this morning in the shower about diffusion of things, and I don't know how it goes.
Okay.
The jet stream probably could play into it. So, I noticed so I've read all 4 of your books. Your first one, Disappearing Spoon, did not have any photographs of major players or anything like that. But as your books went along, I can't speak to the Violinist Thumb since I listened to it. But certainly your last 2 books, you've included photographs of the main players. And even in the Dueling Neurosurgeons, you started each chapter with a rebus.
I did, yes.
And I was wondering how that went over with people. Did people get back to you and say that was fun? Or
with
help, I can't solve this. Like I can't solve this, help.
Yeah.
I mean, I figured this one out, so I feel happy, proud of myself.
Yeah, a lot of people did get back to me. The rebuses, people got most of them. There were 1 or 2 in there that were deliberately more diabolical and tricky. But for the most part, people got the rebuses. Those weren't too difficult to figure. Most of them weren't too difficult to figure out. Right. There was actually a puzzle in my second book, Violinist Thumb. It was an acrostic that was hidden somewhere in the book. And that one is the one that was a little more difficult, that threw some more people off. So
and impossible
out of the,
for me because
yeah, it wouldn't, it just didn't come across in the, unless you were paying very close attention. I would be pretty impressed if you got it from the audio. But
I'll now
that was the,
read it.
yeah, that was the puzzle that was a little bit trickier, I think, was the acrostic in that book.
And decided to go against that. So then as far as adding photographs, was that your idea, an editor's idea? I mean, it makes sense. These are real people. And if, photo exists.
It was kind of a dialogue between us where I decided that because in the later books I was focused a little bit more on the stories were a little bit longer, a little bit more narrative. I was going a little bit more into depth into people's lives. I just decided maybe it would be helpful to actually show the people, to show some pictures of them. So I guess it was more that that's just the way the books evolved a little bit, and it made sense on some level to show the faces of people. So in the Dispering Spoon, there were photographs and pictures, just not headshots of people the way there were in the later books. So I hadn't thought about that, but yeah, you're right that's how things kind of evolved and changed.
Oh, there's a couple. Right. Here we go. There's a few. All right. Found them.
Yeah, but they're less pictures. You're right. There are less pictures of people, individuals, than there are in the later books.
Right. Right. And so I actually like that. That's my 2 cents, but you have to listen to me. I just read a lot of books. And it's nice to just, look. And even though I could go look up what does Joseph Priestley look like and Fritz Albert, and I've probably seen pictures. It's just nice to have it right there.
Exactly, yeah.
And speaking of which, and we're talking about people, and I'm thinking, well, people like to have their heroes and their evil ones, and they like to be clear in their comic book movies and things like, what are we to do about someone like Fritz Albert, who gave us the one thing that saved mankind and then gave us the one thing that could kill mankind? It's so distressing.
It is distressing.
Interesting, but
yeah, I mean, Haber is one of those cases where you can try to debate and say, he was a good guy or he was a bad guy, but it's just going to be impossible to come down on one side or the other. I think almost everyone would agree that he did some amazing things and he did some kind of despicable things. And at different points in his life, he just seems like a really different person. And so, as you said, it is easier sometimes to think about the world in terms of good people and bad people. And, good people don't have to be necessarily all good, and bad people can have some redeeming qualities at some times. But there are some cases where you just can't quite decide. And those tend to be sometimes the most interesting cases. And I think Fritz Haber is one of the more fascinating cases.
Especially
right. And you also... Oh, sorry.
I was just finish up, but especially since it was so extreme, his whole thing of extracting ammonia in order to make the fertilizer was one of the food revolutions of all mankind and things. At the same time that he started making chlorine gas to kill people with.
Poison
and
gases,
that's one of the great scourges is poison gases. So it's not just that he was thoughtful on Sundays and a little bit mean on Tuesdays or something. He did one of the greatest things ever and one of the worst things ever.
Yeah, you're right. It was the extremes that we saw. It wasn't just, a little bad and a little good. It was how good and how bad good and bad was.
He's amazing. Okay.
And I was just thinking then we've got a similar thing, not quite to the extreme of Alfred Nobel. Right?
Yes, Alfred Nobel as well. He invented dynamite, and he did it mostly for good purposes, things like construction work or other things, but he could be pretty reckless sometimes. People died under his watch, and dynamite ended up being a weapon in war, frankly. People were using it to kill other people, to maim other people. And he profited off that to a large degree. So he not only invented it, but he was selling it to countries that he knew were going to use it to kill other people. And what really changed his life was there was a mistake in a newspaper. One of Nobel's brothers died, but they thought that Alfred Nobel had died, and they ran an obituary of him. And, we should all be lucky enough to read our obituaries, because his obituary said something like, "The merchant of death has died." And he was horrified because he realized that his legacy was going to be that he was the merchant of death, that he enabled all these horrible wars and terrible things to take place. So what he decided to do was found a series of prizes, which we know today as the Nobel Prizes, including the Peace Prize, but more often for science prizes. And so his legacy has completely changed just based on the fact that he had a lot of money, he read his obituary, and he decided to endow these prizes. So that's how most people remember him today.
Right. And actually, so nitroglycerin also became as a heart treatment.
Yeah. So nitroglycerin was his big, and he basically learned how to harness nitroglycerin and produce dynamite, which is a safer form of nitroglycerin. And eventually, through some unusual circumstances, doctors realized that nitroglycerin in very small doses is an effective heart medication, can help with angina, heart pain, things like that. And they ended up prescribing it to Alfred Nobel for his heart ailments. And ironically enough, Nobel refused to take it because the nitroglycerin sort of dominated all his thoughts, all his days. He was morally conflicted about it. And he just thought, I can't be ingesting this stuff into my body too. It's going to, almost literally consume me. So he wanted to stay away from it, and did for a while before he eventually ended up taking it.
Yeah. So, and then I mentioned this actually before we went live, but I half jokingly said, you must know all the Nobel Prize winners by now. Because some of these stories you'll start telling, and then you'll say, but he won the Nobel Prize. And I think in the Dueling Neurosurgeons, you had, can't remember his name, but for Kuru disease,
Oh,
we're going on and on and on about finding,
yes.
where is Kuru affecting, and prions and things like this, and people winning Nobel. But then we got this character who's also, also a bit shady. So
yeah, more than a bit shady. Yeah, he was. Carlton Gajusek was his name. Yeah, he was famous for discovering a prion disease called Kuru in Papua New Guinea, but had a very shady background as well. Yeah.
Right. So do you think you could probably write an entire exciting book about Nobel winners, I think?
Oh, definitely. Yeah. There are, as I was saying before, there are so many heroes among the Nobel Prize winners, but there are, a lot of people who frankly had awful pasts or horrible pasts, or who did shady things in order to win the prize. And, science is a human enterprise, and a very heroic one. And overall, I think predominantly it's a good thing. Scientists are good people doing great work. But if you dig into the details, you do find some, unfortunately, some villains in there as well. And they kind of add a little leavening, a little spice. They make it a little more interesting, I think.
Well, if Physics Today had fun with the recent round of announcements, talking about all of the people who kept getting nominated and never won, and why that was. And to some of us, they're very familiar names. And one does sort of end up wondering what in the world was going on. And of course, the Nobel Committee had its own agenda about why they chose not to give Einstein an award for relativity, for instance.
Yep.
But just before the first Nobel Prize was awarded, you passed kind of briefly through, I think, one of my most interesting, one of the periods of physics, particularly, but science, say, that really works for me as a story is the late 18th century, when finally everything was known about physics, and things were calming down, and the rest was just calculating some extra decimal points.
Right. Yeah.
I think when you were talking about Lord Rayleigh, who is obviously a huge figure in the stuff that I did, I've done so many equations that have so many letters in them named for Rayleigh. It's
right. Yeah.
But the way I like to encapsulate that story for myself was Darwin publishes Origin of Species, and he says this could happen. And the one thing he knows is that if this was going to happen, the Earth had to have existed for a very, very, very long time.
Mm-hmm.
So here you have over here the world's greatest physics authority, Lord Kelvin, who comes along and says, this is interesting. Therefore, I will calculate the age of the Earth based on how long the sun could shine as it's currently shining right now. And he says, he does this, and he says to poor Darwin, I'm sorry, but I've calculated this, and it could only have been 20 to 40,000 years.
Yep.
Too bad. Darwin is heartbroken, and I always hear in the back of my mind, well, Lord Kelvin says, I suppose, but based on physics that we know at the time, it couldn't have been more than 40,000 years. And by golly, he was incredibly wrong, except that that was all we knew at the time. And it feels always to me like when he was doing that, and this is where around 1892 or so, boy, was stuff just about to come rushing through the door that would fix that problem. And so I think I like thinking about that story because, you know, Act 2 is going to be so different as soon as you get back from intermission. But
yeah.
I'm sorry. I don't think there was even a question there, but it's just that's just the time I really like. And it was fun to hear about Lord Rayleigh and Ramsay, the guy who had something to do with the discovery of every noble gas.
Noble gas.
Of the noble gases, yeah.
That's an accomplishment, boy. And how anal retentive he and Rayleigh were to start separating out all of these gases. Okay,
yeah,
I was thinking
incredibly
about
precise work they were doing.
Yeah, I was just thinking about my days in the back in the lab. I think it's just sort of PTSD, like flashbacks.
Okay.
So I wonder if you have, and if you care to divulge, do you have an idea for another book, or you're just like, nope, need a break after this one? And
well, my editor and I are talking about some ideas right now, batting some ideas around, kind of going through that list I mentioned before. Haven't settled on anything yet, so nothing to announce, but we should be getting close soon to picking something and getting going on it. So there will be another book, hopefully in a few years, but haven't quite nailed down the topic yet.
Yeah, it takes a while to get this done, and you just finished. This one just came out recently, so
just this summer. Yep.
Yeah. So I'm really glad you're writing these because I enjoy them. So far so good.
Oh, well, thank you.
So, Jeff.
I'm starting to think this is where I get to the part where I write down things that I read that provoked ideas, and I don't always remember why. But I wonder if we could talk for a little bit about explosions and the idea that with explosions, it's how quickly things happen that is deadly, and how that ties into pig number 311.
Yeah, so one of the things I guess I didn't really know in the book is that when you're talking about explosions, obviously you need to be able to pack a lot of energy into a chemical, say, and that is one of the things that makes an explosion, is how much energy you can pack in. But even more importantly than that is how quickly the energy gets released. So with, one of the comparisons I make in the book is that one of the most dense, energy-dense substances we know out there is butter. Butter has a lot of energy packed into it, more energy ounce per ounce than even gasoline does, or something like nitroglycerine. It's incredibly energy-dense. The problem is butter releases that energy very slowly. So it's not good for, say, powering your car or making an explosive. Whereas something like nitroglycerin releases it almost instantly. And it's really that the release, how quickly it is, and the changes in pressure that you get that make it an effective explosive. And then I go on to talk a little bit about, well, that's a chemical explosion. Then you can talk about nuclear explosions, which release energy even more quickly, orders of magnitude more quickly. And that's basically one of the reasons why they're able to produce such bigger explosions. Not only is there more energy packed in there, but they release it more quickly. So after that, I go on to talk a little bit about some of the nuclear weapons testing they were doing right after World War II, especially in the South Pacific. And there's this really incredible experiment they did. And, as I mentioned, experiment is kind of a generous term for it, because
yes.
what they did, Yeah, what they did basically is they had a bomb and they just released it near a bunch of big ships just to see what the heck would happen, because they were curious what the effects were going to be on these big destroyers and cruisers. It wasn't like this well-refined, planned-out experiment. They're just like, well, let's blow it up near this island and see what happens. And one of the things they wanted to study was the effect on living creatures, and they couldn't use human beings, obviously. So they decided to use a bunch of animals. They used goats and rats, things like that, including several pigs. And what they would do is they wanted to test whether that, a sailor's uniform would offer any protection from the radiation, things like that. So they dressed these animals up in little anthropomorphic uniforms, put them on these ships, and they were just sort of running around when the bomb exploded. And one of them was this pig named Pig 311, very close to the epicenter of this blast. No one knows quite how it happened. He was actually locked into one of the toilets on the ship ahead of time, dressed in a uniform, somehow got the uniform off, somehow escaped the sinking ship, and was later found swimming around the lagoon of this island in the South Seas, having survived. And it was sort of this miracle that this little pig had survived this gigantic, huge explosion. And after that, even became something of a celebrity in the United States. Got a photo spread in Life magazine, ended up in the Washington National Zoo in Washington, D.C., because it was incredible that this pig had survived the big bad nuclear explosion. So there's a very strange story in a very strange time in our history.
And speaking of atomic bombs and speeds of explosions, one thing that might reassure some people who aren't aware of this, you had reminded me of this when I was reviewing some things a couple nights ago, is relatively speaking, it's fairly easy to get together a critical mass of uranium-235. Relatively speaking, it's a big engineering feat. The really hard part is getting it together fast enough that the chain reaction actually explodes. So in making the first fission bomb, the biggest technical accomplishment, engineering accomplishment, was not getting the substance, but was figuring out how to make it critical fast enough that it would actually explode. And that's something very hard to do that, your average terrorist in the basement is going to take a while to figure that out, which I find slightly reassuring.
It's somewhat, yeah. So the basic idea is that there are a lot of ways you can, do damage to yourself, usually, with radioactive material, because you can assemble it, you can get it together, you can expose yourself to it, things like that. But it is tricky to get it together in such a way that it will cause a self-sustaining chain reaction and actually explode, like an actual nuclear bomb. So
when you're working on it, treat the radioactive material with some respect, but don't do it out of proportion, because the beryllium that you're over here machining to make a case for it is toxic and will give you cancer faster probably than the radioactive material will.
Yeah, I mean, it depends on the material, but it could be the case. Yeah.
Oh, sorry.
just having fun of your basement lab now, right, Jeff?
No, we're doing fine. And I got nostalgic too, because I was thinking about the early days of the Montgolfiers and all the other people and the exciting stories of balloons and things. At the same time, I was being nostalgic because last year, just about a year ago to the day, I was in New Mexico watching one of the balloon fiesta mornings, and it made me a little longing to be back on vacation.
Okay.
So about how long does it take you to put together a book? A couple years each? Was one?
It's been about a couple of years, and that is maybe a little faster than other nonfiction books in that the chapters in each book aren't independent, but they're independent enough where I can be writing one at the same time that I'm researching another chapter. So I can kind of march along in parallel there. Right. Whereas opposed to, like writing a biography of someone, you'd need to do most of the research kind of ahead of time before you really got down to the writing part. So a couple years each for these books, but the style lends itself well to writing them a little faster, I think.
And I guess when your first book became a national bestseller, that was probably a delight. And
Oh,
maybe,
definitely. Yeah,
and a
yeah.
surprise, maybe. I don't know. Were you thinking, oh wow, I'm actually a writer, or like, you know, how were you thinking about this as you know, it burst
Well,
onto the scene? Everybody loved it.
Yeah, it was strange. You know, I certainly didn't expect it to be a bestseller or to get sort of national coverage, anything like that. I I had been hopeful that if the book reached the right people, they'd be excited about it because even before it got published, you know, I was telling people about some of the stories in there, the premise of the book, and it did kind of capture people's attention, excitement. So I knew that there was an audience out there to some degree, but it exceeded my expectations definitely. So I was very happy with the reception that it's gotten, and all the books have gotten. So I've been quite pleased with it overall.
I was getting down to the giblets, like we said, Joanne, but all these little things. I was really excited or interested or intrigued to read when you wrote, in my words, that anesthesia interrupts consciousness, but we don't really know how. Whoa.
Yeah, it's strange to think about. Like, it's something that's so common, yeah, that we use so much nowadays, but on a basic level, we don't really know what's going on with the brain. We know, obviously, that it slows heart rate, it slows breathing, all those things, but what it's actually doing inside the head is sort of mysterious and unknown. We just know that it works and we use it, but after that, it's just sort of a black box in there. We don't actually know what's going on very much.
I want to say, maybe you should tell us a little bit about the relationship people had with pain, both before and after anesthesia. But I wanted to make a note too, when you were describing Warren and Morton doing surgery for the first time with the with the anesthetic, that when it got to the end of it, Warren said, "Gentlemen, this is no humbug." And I wrote down, I said, in the context of that story, that was a thrilling speech. It was very short, but it was so exciting. I was really thrilled by that.
It was a bit of a climax for that story, yeah. So this is a story in the book where I talk about anesthesia, gases, and really how they changed our approach to modern medicine. Because before that, surgery was seen as something that you avoided at all costs. It was an absolute last resort, and surgeries were usually very short, very quick. They would last 2 to 3 minutes, maybe. You could go into something on the surface, get it out, and that was it, because you couldn't do big invasive procedures when people were squirming, kicking, screaming, things like that. So it basically changed modern medicine to an incredible degree and allowed us to develop these much more complicated procedures that frankly we wouldn't be able to do nowadays had anesthesia not come about. And in the book I explain some of the people involved in developing them, and you know, some of them were great scientists, but a few of them were basically grifters, confidence men. They were scam artists who were doing this, and we owe them a lot. It's sort of a strange story.
Not to mention the little tidbit about the lengthy prevarication some leading male cultural figures went through, wondering whether anesthesia should be allowed for pregnant women giving birth.
Yeah, there was sort of this strange interlude where an obstetrician in, I think, Scotland had developed chloroform, especially for use in birth. But a lot of people said, you know, that there are strictures in the Bible that say that, you know, suffer. Yeah, women should suffer, basically. And childbirth was a curse on them. And they said that if women didn't suffer during childbirth, they wouldn't be able to bond with their children and all these things. So it's a good reminder, an unfortunate reminder, that science isn't removed from culture, that the culture can still affect science as well.
And we still hear those same people. I don't know how they could have lived so long, but they...
They're still around, yeah.
They're still around. The ideas don't die so easily.
Yeah.
So, Sam, we're getting down to the end of the hour, and I'm just wondering if there was anything else you wanted to add that maybe we forgot to ask. Yeah, you wish we had touched upon.
No, I don't think so. I think, the biggest thing I would hope people get out of my books is, as I said, that you can have fun with science. It's an entertaining topic sometimes. There's a lot of serious parts, important parts, parts that revolutionized human lives, human civilization, but there's some really great stories out there because science is a human enterprise. And if you just dig into these stories somewhat, you can find a lot of delightful and poignant tales within them. So it's really what I try to get across with all my books.
That's a really important idea. That's a really valuable idea. And gosh, this book in particular, but all the ones that I've read so far really do that. So thank you for that and for your books.
Yeah, thank you. I haven't been disappointed at all by your books. I love them. I love them.
So I have my last question is a flyleaf question that for the end of the episode. Flyleaf says you've been on things and you've talked to things. So when you were on Fresh Air, did you talk to Terry Gross?
I did talk to Terry Gross,
so tell me what she's like. I really admire Terry Gross. I just want to know.
Okay, it was a fascinating interview. It was just fun to talk to her. She's so smart, and so she's just so interested and excited about the topic that it's just it was really great to talk to her.
Yeah, I think she's my unadmitted role model probably.
Okay. It was sort of charming at the beginning of the interview. She got on the line, and I wasn't in the studio with her. We were connecting remotely, and she said, "Hi, Sam, I'm Terry Gross. I have this show on NPR." And she was almost introducing herself to me as opposed to the other way around. So very charming, very humble. It was a great interview.
Would have been surprising if you said, "Oh, I've never heard of it."
Yeah. Like, sorry.
What? Oh, okay. Well, that's okay. I'll talk to anyone.
Yeah.
So, Sam, thank you so much, first of all, for coming on and for writing your books. And everybody, just one last reminder, his latest book is Caesar's Last Breath, Decoding the Secrets of the Air Around Us. Still out in hardback because it's really new. So if you've read his other books, make sure to get that, or, well, whatever your status is with Sam Kean books, go ahead and read it. So, thank you, Jeff.
Sure. Thanks, Sam, so much.
Thanks, Jeff. Thanks, Joanne. All right.
Thanks, everybody, for tuning in.